Hello everyone, welcome to another problem solving session with GMAT by example. Now about 40% people get this question wrong, which makes it medium to high difficulty level question in official guide to GMAT book. And here's the thing, we have seen these kind of questions over the years in official guide to GMAT, which means that it is one of those popular kind of questions. And the reason why people keep getting these questions wrong is because there are some fundamentals that you need to really grasp before you start solving questions of this kind. If you see this question for the first time without having those fundamentals, then there is a high chance of you actually missing out the question and getting it wrong. So in this video, I'm going to talk about those fundamentals first and then jump into the solution of the problem. And I guarantee that you will see that once you understand the fundamentals, the problem reduces from a medium to high difficulty to an easy level problem. And as you know, I personally respond to all the comments on my videos. So if you have any lingering questions, or if you want me to solve another similar question on official guide or any other source, please let me know. Okay, so let's get started. So this is a special category of problem in solid geometry, which is called a fit problem. And here is the thing. The first thing that you need to understand is, what does volume signify? So if I had a cubical box of 333 units of dimensions and I was going to fill this box with 18 cubic units of sand, things would have been easy. I can very easily figure out that since 3 multiplied by 3 multiplied by 3 is 27, the sand can easily fit into this box, and I can even go one step further and figure out if the base is 3 multiplied by 3, which is 9, the height would be 2, which makes it 3 multiplied by 3 multiplied by 2, which is 18 cubic units. So that is when you are filling in sand, which can take any shape and form. But what happens if instead of sand, you put in a solid into this cubic box? This is where the volume is not going to help you. Let's say I have a can of 16 cubic units. I'm not giving you the shape of the can, any of the sizes of the can. All I'm giving you is the volume of the can. It is 16, which is less than the 27 cubic feet. And my question is, can I fit that can into this volume? And the answer is, you don't know. It does seem like you should be able to, but the answer is you don't know. And I'll give you an example why. Let's say the can is actually in the shape of a cuboid of dimension 4 to 2, right? So this is 4 multiplied by 2, 8 multiplied by 2, 16. So it is 16 cubic feet. However, when you try to fit this into this cube, it will never fit because one of the sides is 4, which is always greater than 3. And this is the crux of these kind of problems. When you are considering solid shapes, volume is not enough. You need to know the dimensions of all the solids involved to actually answer the question. That is one of the most important things, but that is not all. But let's write it down before we get to the next layer of the problem. So first layer of the problem is volume is not enough, must know dimensions. Here is the second degree of difficulty attached to these problems. The cube, for example, has a thickness to it. Outer layer is 333, but it has a thickness to it, and let's say that thickness is 0.5, making the inner volume actually 2 multiplied by 2 multiplied by 2, and that is entirely possible depending on what the shape of the cube is. So what you can actually fill is only 2 multiplied by 2 multiplied by 2, not really 3 multiplied by 3 multiplied by 3. What that means is, for the enclosing container, the container that you're trying to fill stuff in, you have to know the internal dimensions. So just having the outer dimensions is not enough. You really need to figure out what the internal dimensions are. And if the internal dimensions are not given, then you may be in trouble. So let's write that down. For the enclosing container, I must know not just the dimensions, but the internal dimensions, right? Now, then there is a container that you are going to fit inside the enclosing container, and for that you need to know the outside dimension. It doesn't matter whether it is thick or thin inside, as long as you know the outer dimension, then you know whether it will be fit or not, right? For example, if instead of this I had a cube which had dimensions of 222, I would be able to fit exactly one cube inside this box of internal dimensions 222, the container that I'm trying to put inside the enclosing box. It doesn't matter what its thickness is or what its internal dimensions are, because it doesn't matter to me. For the fit, all I need to know is the external dimensions container. So for the container that needs to be fit inside the enclosing container, I need the external dimensions. I don't care about its internal dimensions. It could be a solid or it could be hollow. It doesn't matter. And finally, there is a inherent assumption in all of this is that you cannot crush these things, right? If you're given a shape and size, you cannot crush these things. So these are not crushable cans. When you're trying to fit them, you cannot change their volume and dimensions. They are going to stay solid, right? This is not about how many of these can you crush and put it in, because that will change the question. So that is the third postulate that you should remember in solving these problems. Cannot change the volume unless the question actually gives you explicitly that you're changing the volume in some way. You can make an assumption that these volumes and these dimensions cannot be changed and try to solve the question from there. So let me just quickly review. The first thing is volume is not enough. We really need to figure out the dimensions. We also saw that just the dimensions are not enough. For the enclosing container, the container which is going to fit other things, we need the internal dimensions. The external dimensions are of no use to us. The internal dimensions is what decides the space where other things are going to fit in. And for the containers or boxes or other shapes that are going to be fit inside the enclosing container, we really need to know their external dimensions. Their internal dimensions are of no concern to us. So when we are trying to solve problems like this, these are the three informations we have to determine. And if we cannot determine any of those informations, then the answer is insufficient. Once you have understood that, the question is going to be very simple. Let's jump into the solution and see if we can get an answer. Instead of you bearing through my handwriting, I thought it would be better to use a PowerPoint font. So these are the postulates that we are going to use for solving this question. So the question really asks how many cans in a carton without giving us any of the information regarding the cans or the carton. The carton here is our enclosing box, so let's write that down. And the cans here are the things that we are trying to fit inside our enclosing box. The interior volume of the enclosing box is given to be 2304 cubic, and you know we need dimensions, not just volume, so this is not going to be sufficient for us. The exterior of the can is given to us, so we are following the postulate number 3 very well. We are given the exteriors of the can, and since we are given that the can is a cylindrical in shape, we can find its volume. However, we need all of this information, right? So we are not given, for example, internal dimensions of the enclosing container. We are given this, and since one of this information is not given, again, determining a fit is going to be impossible, insufficient. When we combine these two statements, we are definitely given the size, but there is no way to figure out what are the internal dimensions of the enclosing container. We may be given the internal volume, but again, we need the dimensions of it. So even combining them, we have insufficiency in the data. So the answer to this question is E. If you follow these postulates for all of the questions of this kind, you will seldom go wrong. So take a note of this postulate. If you found this video helpful, please do not forget to like the video and subscribe to my channel for more such videos.